Hello, Algebra 1 students, and welcome back to your Semester 2 final exam review. Today we're looking at problem 29, and you can see more examples of this in lesson 7.2. They ask us which of the following quadratic functions represents the graph to the right. What I would suggest you do is, instead of starting with the four answers, because those can be a little bit confusing, start with the graph to the right. And we can realize by looking at the four answers, especially C and D, that these are looking to me to be a lot like vertex form answers. So what I'm going to do is go y equals a x minus h squared plus k, and then I'm going to leave some blanks. A blank for a blank for h, a blank for k. And I'm going to start by finding those values. We should know that h and k in vertex form correspond to the vertex. It looks like the vertex of this graph is 0, negative 5. So I know my h, opposite of positive 0, you could put minus 0 or plus 0, doesn't matter. And then k, minus 5. Then we're going to find the a value. As a reminder, the a value can be used to find a point in one in each direction horizontally. So I'm just going to go over 1, even though I know it's rise over run, we're going to go over 1 because that's as far over as we can go, and then up however far. In this case, it looks like it's up 2 over here as well. So if we think about the rise over the rise is 2, the run was 1. This is my vertex form equation that matches the parabola. And in fact, it's my vertex form equation that matches one of these answers. So let's simplify this down a little bit. Okay. As we simplify, we should realize that 2 over 1 would almost certainly just be written as 2. And then x minus 0 squared, well, we don't actually need a minus 0. That's not really doing anything. So we can just put x squared, and then the minus 5 at the end. Can you see the answer now? Hopefully you can identify that answer as B, right? 2x squared minus 5. Now, if we thought about the other equations and thought about what they were telling us, I tried to give you two ways to find an answer here. I'm going to clean up my graph a little bit. The first thing we can do is we can realize that these are in HK form, and the h's are always inside the parentheses, and the k values are at the end, after the exponent. So C and D clearly have zeros at the end. A and B, though, are pretty tricky, and they throw a lot of people off. A and B, we can always put an h value in here. So 1/2. The h value always goes between the x and the square. Can you see the h down here? It's in between the x and the square. So I could do an x and a square, and there's still a minus 5. Same thing over here. X, square, and minus 5. If there is nothing in between the x and the square, we are always able to add or subtract nothing. We can add or subtract. Doesn't make a difference here. Because if you add or subtract nothing, you're not actually changing anything. So we have these four equations. From here, you should identify the vertex. Vertex-wise, we can see we're at 0, negative 5, 0, negative 5. These guys, opposite of h, so opposite of 5 is negative 5, 0, and positive 5, 0. So just by quickly graphing the vertices, the vertexes, you can eliminate two of the four answers. 0, negative 5 matches, 0, negative 5 matches. Negative 5 zeros over here, that one certainly doesn't match. And 5, 0 over there, that one doesn't match either. Then you can go back and look at the a values. Now, as a reminder, to use an a value that's a fraction, and this is pretty tricky, a lot of people mess this up, we don't go up 1 over 2. Because your a value, if you're going to use it to find more points for a parabola, always needs to be written over 1. And so what this tells us is we're going to go up 1/2 over 1. So this would mean go up 1/2 and then over 1, up 1/2 over 1. We would not want to go up 1 over 2. This point would not actually be on a parabola that has an a value of 1/2. Clearly, though, those points do not end up on the parabola, so a is out and b is our answer. Again, I think it's a little bit faster just to write the equation and then see which one it matches, but if you wanted, you could go through each equation the way that I did, find which vertex matches up, and then go from there. So Thank you for tuning in. Hopefully that was a pretty nice review of how to graph parabolas in HK form and helped you through problem 29 on your final review. I'll see you back later on.